Hey everyone, and welcome to The Explainer. Usually, I like to kick things off by giving you a clear roadmap of exactly what we're going to cover today. But honestly, scratch that. I'm actually skipping the agenda right now because I want to preserve a massive surprise we have for you later in the presentation. Let's just say we are going to start with the ultimate science fiction scenario, and by the end, we're going to end up confronting a very profound and very real planetary reality.
Okay, let's dive into this. What would actually happen if the Earth suddenly stopped spinning? It's kind of the ultimate terrifying thought experiment, right? I mean, you're sitting there right now, probably feeling completely stationary, but the wild truth is, we are all strapped to a giant rock hurtling and spinning through space. So what happens if someone just slams on the cosmic emergency brake?
To set the apocalyptic stakes right off the bat, let's look at this incredibly blunt quote from astrophysicist Neil deGrasse Tyson. When he was asked this exact hypothetical question by Larry King, Tyson didn't mince words. He simply said, "That would be disastrous. It would kill everyone on Earth." Just boom, end of story. But why? Why would a sudden stop be so instantly fatal for literally every living thing on the surface of the planet?
Well, the answer lies in the textbook physics of our everyday existence, inertia. Now, what's really interesting about this slide is how it breaks down Sir Isaac Newton's classic rule, which is that inertia is the tendency for an object in motion to remain in motion. You see, right now, you don't feel like you're moving, simply because everything around you, the air, the buildings, the ground, it's all moving at the exact same constant speed you are. But make no mistake, you are definitely moving.
And that brings us to momentum. Momentum is literally just mass in motion. It's calculated by taking an object's mass and multiplying it by its velocity. Because you have mass, and because you are moving right along with the Earth's rotation, you possess a massive amount of momentum. If the planet suddenly hits the brakes, your body's momentum dictates that you are going to keep moving forward at the exact same speed you were traveling a split second before the stop.
And this brilliantly illustrates what that looks like in the real world. Think of a football player taking a brutal, full-speed tackle. The player is brought to this sudden, violent stop, and all that forward momentum has to go somewhere, usually resulting in a crushing impact. If the Earth stopped, we would be that player, except the tackle would be us colliding with the atmosphere and our surrounding environment at supersonic speeds.
Let's look at the actual numbers here to compare the human scale with the planetary scale. If you happen to be standing at the equator, you are currently rotating at over 1,000 miles per hour. As you move north or south, that speed decreases until you hit the poles where you're barely moving at all, basically 0 miles per hour. So if the Earth suddenly halted and you weren't miraculously seatbelt buckled to the bedrock, you would violently fly eastward at up to 1,000 miles per hour. You'd be tumbling across the ground faster than a commercial jetliner flies.
Let's move to and see how this builds, because this momentum doesn't just apply to humans and buildings. The very shape of the planet and our oceans relies completely on that spin. Right now, the Earth's rotation creates a centrifugal force that literally pushes ocean water toward the equator, which creates this massive 8-kilometer-high oceanic bulge. Because of this, the planet itself is an oblate spheroid. If we stopped, that centrifugal force just vanishes. The oceans would immediately collapse and migrate toward the poles, and the Earth would become a much more perfect sphere.
The geographical fallout from this, it's pure dystopian nightmare fuel. As the oceans drain from the middle of the planet, a massive, continuous megacontinent would emerge, wrapping all the way around the entire equator. Meanwhile, regions like Siberia and northern Canada would completely drown under these new, deep polar oceans. Add to that the loss of our magnetic field because the planet's core stops spinning, and half the planet being locked in permanent freezing darkness, while the other half just bakes in endless, relentless sunlight.
And honestly, if that wasn't enough, the sheer kinetic energy of a sudden stop has to be released somewhere. The incredible angular momentum ripping the surface apart, combined with the bombardment of falling debris that was just flung into the upper atmosphere, it would generate so much heat that the Earth's crust would literally liquefy into a molten ocean of rock. It is absolute, total destruction. Part 1. The reality twist. Earth is actually slowing down right now. Because while a sudden stop is physically impossible, we are pivoting sharply from science fiction to science fact.
Just look at this number, 1.33 milliseconds. That is the current rate our days are lengthening every single century. Now, okay, after talking about 1,000-mile-per-hour winds and melting crusts, a fraction of a millisecond sounds completely trivial, right? It sounds like a rounding error. But seriously, do not let this tiny number fool you.
As researchers have pointed out, this rate of deceleration is unprecedented in 3.6 million years of geological history.
Think about that. For millions of years, the gravitational tug of the moon has been the primary factor slowly tweaking our rotation. But today, the forces required to shift the rotation of an entire planet at this new, accelerated rate are historically massive. And what is driving this unprecedented shift today? It's climate change.
So the crucial point is, it all comes down to the conservation of angular momentum. In physics, when mass moves away from the center of rotation, the rotational speed slows down. Think of a spinning figure skater on the ice. When they want to spin faster, they pull their arms in tight to their body. When they want to slow down, they extend their arms outward. Believe it or not, the Earth is doing exactly that right now. Let's walk through the exact mechanical steps of how this is actually happening. Step 1. Rising global temperatures melt the polar ice caps and high-latitude glaciers. Step 2. All that meltwater, which was previously locked up as ice near the poles, the axis of our spin, flows into the oceans and moves outward toward the equator. Step 3. This adds extra mass around the middle of the globe, causing the Earth to bulge further at its waist. And Step 4. Just like that ice skater extending their arms, this physical redistribution of mass slows the planet's rotation. You really have to grasp the staggering scale of what we are talking about here. To slow the Earth by just 1.33 milliseconds requires the movement of roughly 1,000 gigatons of water from the poles to the oceans. Try to visualize that amount. Picture a solid cube of ice placed directly over New York City, and it's reaching 10 kilometers into the sky. That's taller than Mount Everest. The sheer energy involved in changing the Earth's rotational speed to this degree is equivalent to a magnitude 9.0 earthquake. That is a massive planetary scale force, and it's entirely driven by human impact.
And look, this isn't just some abstract physics problem for academics to debate. There are highly practical consequences for us. That tiny millisecond fraction actually disrupts the ultra-precise timing required for GPS navigation on Earth, which our smartphones, planes, and global supply chains rely on. It even affects spacecraft navigating our solar system. Furthermore, this profound mass redistribution goes hand in hand with extreme weather events and rising sea levels, posing a direct threat to safe human habitation worldwide.
I want to read this quote directly from Professor Benedikt Soja from ETH Zurich, who co-authored the study on this phenomenon. He says, "The most important takeaway is that human influence on the Earth system has become so profound that we are now changing the very way our Earth spins." Let that sink in. We are no longer just looking at localized pollution. We are looking at cold, hard scientific data showing that human activity is literally altering the planetary mechanics of the globe itself. Which leaves us with a rather profound and, honestly, unsettling question to ponder as we wrap up. If we are genuinely changing the very way our world spins, what else are we altering? It's a pretty stark reminder of the incredible scale of our footprint on this planet. Thank you so much for joining me on this explainer. Keep questioning, keep learning, and I'll see you next time.